Welcome to the stream. It's been a while since I streamed, and I thought that this is not a good thing, and I will try to be more consistent. Please March. Although I solved some questions off the stream, and GCD partition, maths problem. While at Kira's house, Joska saw a piece of paper on the table with a task written on it. The task sounded as follows: array of length n. On this array, do the following: integer k, split the array into k subsegments, calculate the sum in each of subsegments. Subsegments, what is a subsegment? Pair of k numbers. Let's write first the given information. GCD partition. A1, A2, A3, AN. Select an integer k greater than 1. K subsegments. What is a subsegment? Division in k pair of numbers. L is smaller than R for every j. L1 is always 1 and RK is always n. This is always 1. This is R1, then L2, R2, then Rn, K. For every li less than hmm, J Lj plus 1 is equal to Rj plus 1. L2 is R1 plus 1. Hmm. Indexes. Lj plus 1 is equal to Rj plus 1. 1, 3. Then if this is 3, then next will be 4. Then this, if we take this as, this should be greater than 4. If we take this as 7, then next should be 7 plus 1, 8. Then this can be 9. Next should be 10. Okay. Plus 1. This is always L1 and this right, this is always an RK. This is pair 1, pair 2, pair 3. Calculate the sum in each of k segments and write the sum to another array. Each of k subsegments and write the sum to another array. G is equal to L to R. The final score of such a split will GCD. Sum. What is sum? Score of such partition will be okay. Sum is Al plus Ar subsegments K pair 1 pair. This is B. BI. Then GCD will be our answer. GCD of this sums. AL1 plus AR comma AL2 plus AR2 and so on for K elements. The task is to find such a partition as maximum scope possible. So elements are 2 into 10 to the power 5. And AI is in int range. So the expected time complexity is less than n square and log n n square is not allowed. It's this question asks for many problems. We have multiple steps. First, we have to decide the subsegments. First, we decide subsegments. Then we have to calculate sum for each subsegment. These will be our new elements, and we have to calculate then GCD for these elements. GCD greatest common divisor. HCF. Okay. And this condition is also important. This one. So we can only have in sequence elements. Let's see the test case. 4 to 2 3. plus 2, 3 plus 4. The fourth test case, okay, this one is easy. Fourth test case. Okay. So we can have more than. This is a subsegment, okay, not a pair. Hmm. We cannot sort the array because then order will be disturbed. GCD of this array is 1. Hmm. If we want sum between these two indexes, we can have a prefix sum array and prefix 5 minus prefix 3 plus next 3 will give the 3. We can have one element also in the subsegment. Okay. Less than equals. Okay. We can also have one element. Okay. So we can hmm, maximum GCD. Okay, we have maximum GCD. This is summation. Okay. L2. GCD properties. Prime factors. Greatest common divisor. and decide k is equal to 2. We can have first k from 2 till n. Two groups. This represents if we divide in half. N by 2, 1 by 2 plus 1 n. This represents all elements itself. So we will have n elements. Hmm. Hmm. For some of this, okay. We will use prefix sums for summation calculations. GCD of GCD function will run n times, and from one time to this can run. We can have a for loop going from here. First, if we divide this, if we have then prefix sum we can get in constant time. This will for making it pre of R minus pre plus A. We can get this and we can run a for loop for calculating the GCD. How do we divide this into subsegments? If we want to get maximum, first way is if we try for each subsegment, then this will be constant. If we divide it into subsegment, then calculate GCD for each k and get the maximum. So how do we optimally select the k? Because if we get k, then I think we can easily solve the problem once we divide the subsegment. This is linear search on k. Approach one is, let's write it down. The linear search on k, where k is bounding from 2 to n, and first we have to pre-calculate the prefix sums in n time, linear time. Calculate prefix sum. Then linear search on k, where we will be calculating the GCD. Now calculate GCD for this subsegment corresponding to this case. So this will lead to of n into first one divided first we selecting the k, then this step. For each comparison. Can we do binary search on k? Is this a monotonic function? Because if it is a monotonic function, then we can easily do a binary search on k. GCD is monotonic. Let's select in this test case number 6. Told me prefix summary will be 0 base index 1 3 4 5 6 9 0 1 3 4 5. Okay. First we made this, then we have to search for the k. K can be from k is equal to 2 to n here is 6. So if we take mid is 6 plus 2 and get 2 4 in 4 subsegments. Okay, if we want to divide it into 4 subsegments, we have multiple options. We can divide it in this manner. We can divide it in evenly manner. Can have 3 elements here. 1 element here, 1 element. Maximum GCD. This will be resulting in someone. This will give some 5 minus 3 2 plus 2 4. Prefix. Okay, prefix 5 minus 1 minus. Okay. If we want to get the sum between these two elements, between this prefix 3, 5 minus 1. 4. And if we want to add this in, this will be 6. 6 plus 1. Hmm. GCD is one for this key and all the cases. If we search in smaller subsegments, then that will result in bigger sums. If we search in larger K, then more divisions of the array. But it is not guaranteed. If we try to go from bottom down instead of going the top down sequence, if we go from here and we try to maximize GCD, first let's see, start from the last step, B2, B3, BN. We want to maximize its GCD, DI, and what should be the case? Prime factorization. Biggest prime factor which is common and We can calculate factors in root and tan for one element. Mm, Minimum is one. Maximum is if one of if all the elements are same. We want as answer. G should be equal to 1. Yeah, I'm not getting an idea. Where should I? How should I proceed with this problem? We want this B array to have its element all have some common factors, even if a pair does not have, then the answer will be 1. Base summation हो कि if we start from k subsegments, this will be is equal to A1, A2, A3, A4, AN initially, always. Then we try to combine them. N is less equal to 5. A5. Let's see then. Why does merging two segments in a three-way split show that using more than two subsegments can never be optimal? Using more than two subsegments can never be optimal. It is possible. K is fixed for a. But if it is fixed also, it is possible we select K as this. 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 So first hint suggests that always K is equal to 2 is of K greater than 2 can never give answer. But how to reach at this conclusion? I think I will end this stream because I will have to see it more deeply. So I will see the problem once again after the stream and will explain it in my words tomorrow.